It's Dr. Goose here to talk about my favorite Satisfactory resource, water. This is 800 cubic meters per second, which is 48,000 cubic meters per minute, or 211,338 gallons per second, which is equivalent to the Storforsen Falls, Sweden's largest natural waterfall. It's about a third of what my Terrafactory design needs, which is slightly more than Niagara Falls at its peak flow rate. This water is going to be provided by 1,400 water extractors, which produce 120 cubic meters of water each, or 2 cubic meters per second. So why do I keep converting units? Because a lot of recipes in Satisfactory rely on water, and without a way to compare water's value between them, we don't know which recipe to choose. While it's virtually unlimited, since extractors can work forever in any body of water, and there's plenty of water on the map, the water isn't free to get. Each extractor is consuming 20 megawatts, or 20 megajoules of energy every second. So for each cubic meter of water we extract, we spend about 10 megajoules, meaning the Terrafactory pulls 28 gigawatts just to extract its water. If we were to package and sink all 740,000 gallons per second, the 168,000 packaged water would sink for 21,840,000 points at 130 points each. Subtracting the 60 points that each container was worth, which is 10,080,000, this gives us a net profit of 70 points per cubic meter of water, or 11,760,000 points per minute. When any machine in Satisfactory is under or overclocked, its energy efficiency changes. I ran a series of water extractors at different clocks from 0 to 250%. Power draw follows the power law, with 0.047 times the overclock percent to the 1.31 power. This means that when a machine is underclocked, it draws less power, and when overclocked, it draws more, okay? However, a machine's output is linearly dependent on the overclock. For water extractors, it's about 1.2 times the overclock percent. So by combining the two metrics, the power and the points, we can get a score or an efficiency of the process. Remember, for water extractors, at 100% clock speed, we score 420 sync points per megawatt. Doing the same at some other clock speeds reveals another power law trend, 1,759 times the overclock to the power of minus 0.31. This negative power means that our score has the opposite trend from power draw. As we underclock machines, not only do they use less power, but they run more efficiently for the items they produce. So if you have extra room and want to lighten the energy load, like that 28 gigawatts for water, build more of the building and underclock them. Now, you can't rely on just shutting down production. If you have one extractor at 50% clock, it's using 8 megawatts of energy. But the same extractor at 100% clock and only running half the time uses 10 megawatts. Now, I just want to say that I'm blown away by the response to my last update video. The flock has doubled to over 2 to the 10 geese, which is absolutely wild, and I love seeing all of your builds. So for this one, please post all of your water management and water mains in the comments. I want to see them. Follow along to help the flock hit 2 to the 11, and in part 2, I'm going to cover fluid handling and teach you how to build priority fluid mergers and some other tricks that means your machines will never stop up and you don't have to worry about doing the recycle math. It's just going to auto-regulate.